Good morning or afternoon, and welcome to the year-end wrap-up for our fourth year of the Food Safety Matters webinars. I am Miriam Eisenberg, and I will be your moderator today. I'm the manager of Food Safety and Public Health with the EcoSure division of Ecolab. I support over 200 field specialists and our operation teams providing food safety and brand standard third-party audits to chains around the U.S. and Canada. And I'm very pleased to be part of this series for these 4 years. Ecolab appreciates your continued support for this program, and we hope that it will be an exciting webinar for you today. We're taking a slightly different approach. In the past, we have used our December webinar to recap the year, but for today, we are presenting 5 mini-sessions, which will give you a brief overview of some of those topics that you've asked about in the post-webinar surveys throughout the year. Then with our remaining time, we're going to have an Ask the Expert period of time. And during the presentations, don't forget to use your Q&A panel down at the lower right-hand corner. The 5 mini-sessions that we're having today are going to cover warewashing and food safety regulations, biohazard preparedness, thermometers and all the different choices, sanitizer and wiping cloths, a FSMA update, and then at the end, Ask the Expert. Joining us for that portion will also be Dr. John Barkay, who is a senior scientist with Ecolab Pest Elimination. So don't forget to send in any of your insect or other pest questions, really any food safety questions that you might want to send to the panel. Try to challenge us today. And as I mentioned, these will be brief. They're going to be more or less 20,000-foot summaries on these topics and are not meant to be all-inclusive. You can let us know via future surveys what other topics you'd like to hear about, whether they'll turn into mini-sessions or to full webinars. And with that, I'd like to pass this over to Frank Bocci, who will talk about warewashing and food safety regulations. Go ahead, Frank.
Thank you, Miriam. As Miriam indicated, my name is Frank Bocci, and I'm with Ecolab's Food Retail Services. I provide technical support for approximately 300 field representatives and have held various technical and project management roles within the Ecolab organization for the past 20 years. This afternoon, I'll be providing a brief presentation on warewashing and food safety regulations. The 2013 Model Food Code provides minimum requirements for commercial warewashing machines. It specifies that all units must have an affixed data plate that provides unit specifications. It must have a visual means of detergent delivery, as well as a visual and/or audible alarm in the event no product is being dispensed. It also specifies temperatures for both hot water and chemical sanitizing, as well as a different concentration for various sanitizing agencies. And I'll read this part specifically in the Food Code. There's a chapter titled Acceptability. Food equipment that is certified or classified for sanitation by an American National Standards Institute, or ANSI, accredited certification program, must comply with Parts 4.1, which speaks to materials of construction, and Parts 4-2, which speaks to design and construction. The information provided on this chart was pulled from Section 4-5 of the Food Code, which provides maintenance and operational guidelines. This includes machine types, minimum wash temperatures, as well as minimum and maximum rinse temperatures. Interesting to note here is that the code does allow for a single temperature machine as long as that machine provides both wash and final rinse water temperatures of 165 degrees Fahrenheit. And to this point, in any warewash unit where hot water will be the method of sanitization, 165 degrees Fahrenheit is the minimum temperature the surface of the ware must be raised to for an effective sanitization step. As is true of all sanitizing agents, in a mechanical warewasher, they must be used as per EPA registered label. The Food Code provides temperature and concentration ranges for chlorine, iodine, and quaternary sanitizer solutions. An alternative sanitizer may be used as long as it is listed in the Code of Federal Regulations 180.940. And an example in terms of other sanitizing agents, one might be a peracetic acid. But again, a full list of these alternatives can be found on the internet. Now I'd like to briefly touch on NSF Standard 3, which speaks specifically to commercial warewashing equipment. This standard establishes minimum public health requirements that includes materials, design, and construction and performance for all types of commercial warewashers. In order to meet NSF Standard 3, each make and model of a commercial warewasher must pass a number of performance tests. Those tests include cleanability, and in this test, the case means how effectively can a unit remove dried buttermilk from a surface of wear. Sanitization. In hot water sanitizing units, the surface temperature of the wear is monitored throughout the wash, rinse, and sanitize cycles. In the case of a single temp unit, that temperature is 165 degrees Fahrenheit. And then they also check to ensure that the thermostats within those dish machines work appropriately. In other words, does the thermostat register when the temperature drops and turns on a heating element, and when the water reaches the proper temperature, that heating element is turned off. NSF Standard 3 specifies that the following information must be permanently fixed on the data plate: the minimum wash and rinse water temperatures, minimum wash and rinse cycle times, max and minimum rinse line pressures. For chemical sanitizing units, the type and concentration of the sanitizing agent. And with units with the conveyor speed. All units that have been certified to NSF Standard 3 must bear the mark of the entity that certified the unit. An example of this might be Intertek. Intertek is an independent multinational inspection, product testing, and certification company. Their listed mark is designated as ETL. So in other words, NSF is responsible for the standard, but other authorized testing agencies may perform the testing and provide that machine or guarantee that that machine meets the NSF 3 standard. In conclusion, I'd like to recognize Aaron Burke of Ecolab's Regulatory Affairs Department, who was responsible for obtaining the information provided in this presentation. Unfortunately, Aaron is unable to attend today's session. With that, I'd like to thank everyone for your time and attention this afternoon, and would now like to turn the floor over to the next presenter, Miriam Eisenberg.
Thank you very much, Frank. I'm going to spend the next few minutes going over the highlights about how you should be prepared for any biohazard contamination in food service and retail, and how to be ready to prevent any contamination that might occur. First, in terms of biohazard, I'm focusing this mini presentation on biohazards in terms of food service and retail. So we're really talking about human contamination from bodily fluids such as vomit and diarrhea or any fecal contamination or blood. The more likely situation, obviously, in food service being vomit and diarrhea. For those of you who are in the middle of eating your lunch, I do apologize for some of this content, but when we talk about foodborne illness, we can't avoid the topic. And why do we need to worry about this? Well, the concerns are that vomit and diarrhea are means of spreading illness, the most common being norovirus. And we're actually in a norovirus season now, which does coincide with the influenza season. And so the more we can heighten awareness and minimize the impact of norovirus, the better that is. And another reason I wanted to highlight this today is that the requirement for having a procedure for biohazard cleanup was added to the 2011 Food Code Supplement, and that you can find this information again in the 2013 Food Code in 2-50111. And besides looking at the actual text of the requirement itself, I also encourage people to look at Annex 3 as well, which will give you more background information, which will help with training and understanding why we're doing this. But what this is stating is that you must have a procedure in place that your employees are trained on, so if there is a vomiting or diarrhea accident somewhere in your facility or in the restroom, that people know how to react, that they know how to do the proper thing to minimize the spread of any contamination to guests, employees, or other family members, because you can even take the norovirus back home with you, and you want to prevent that as well. So why is this proper cleanup so crucial? As I mentioned, norovirus, which very often is what you actually have when you have what you call a stomach flu, causes vomiting, which is often explosive, and also diarrhea, which could also be explosive, and this is going to contaminate surfaces and can become airborne. If you think about an ill person contacting tables, chairs, the floor, dishware, surfaces in the restroom, there's many opportunities to spread these kind of viruses. And norovirus is highly contagious, with just small amounts being required to spread it from one person to another. There's been a study that also explained that employees who were cleaning up vomitus were more likely to contract illness than those who did not. And very often this can be associated with not having the proper procedures in place. In the past, before there was such emphasis placed on proper cleanup, it wasn't unusual for someone to run to the kitchen, grab a mop and bucket, and start mopping away when someone has a vomiting incident in the dining room. This is not the correct procedure and can cause more problems by spreading the contaminants and also making it more airborne. So in terms of giving you really just kind of a brief step-by-step of what you can do to get ready, the first thing you want to do is get proper procedural information. And I recommend contacting your chemical provider for the information that you're going to need regarding chemicals and other products that you need to use. Now, you'll get information regarding non-blood spills as well as blood spills, and as I mentioned, we are focusing on non-blood spills for this presentation. And if you get the right tools and information, that's where you can start. And I'll also mention that the 2013 Food Code, which did emphasize this, is being adopted more and more by different regulatory agencies around the country. So if you haven't put these procedures in place, now is the time to do that. If you're part of a corporate group, generally that information will come from the corporate entities, but if you're with a single unit, talk to your chemical provider so that you have what you need as well. And then you're going to get your proper cleanup gear, chemicals, and materials. I am showing an Ecolab kit here just as an example, but you can assemble a kit with the proper tools, again, by working with your local chemical provider. And it will include such items as a disinfectant, which is certified against norovirus, mask, gloves, absorbent powder, scoop, a plastic disposal bag, and then different kits may contain different items. You don't have to buy specifically a kit, but you can also put together the different implements once you find out about necessary procedures. And then obviously, proper training on the procedures is going to be quite critical. The first thing you have to unteach people is you do not go and grab a mop. Some of the kits or other tools you can buy, it may even contain a plastic sheet that if someone does vomit, the plastic sheet can be placed over the vomitus or the diarrhea to begin with. But then as you see here in the upper left-hand corner, the first step you see the liquid mass has been covered with a powder, which turns into a gel, and then a viral disinfectant is sprayed on top of it. And then with a gloved hand, and I'll mention also that the person would have a mask on as well, would be scooping up this gel material, disposing it into the plastic bag that comes with it. The scoop is also going to be discarded. And then after final disinfection, after the cleanup, everything is going to be thrown into the bag, which will be sealed for disposal. And then it's also very important that after the cleanup has been completed, that you do replenish the supplies so that you do have them on hand. Sometimes I've been asked, well, how do you know if someone's actually sick or if somebody has perhaps had too much to drink? Whenever there's a vomiting situation, you always will approach it as if it might be a contamination issue. You don't try to minimize the situation by doing something inappropriate. Now, again, that was just a very brief overview of biohazard preparedness, so contact your chemical supplier for more information. And with that, I would like to turn this over to our next presenter, Cindy Rice. Cindy?
Thank you, Miriam. My name is Cindy Rice. I am a food safety specialist with Eastern Food Safety and also a consultant to Ecolab Food Safety Specialties. I'm going to talk a little bit today about thermometers. Time and temperature abuse is a major contributor to bacterial survival and growth in TCS foods, and it comprises 2 out of the CDC's 5 most important risk factors to foodborne illness in the industry, namely improper holding temperatures for TCS foods and improper cooking temperatures. So the FDA 2013 Model Food Code addresses the importance of temperature controls in retail establishments in several sections. In Chapter 3, the FDA outlines requirements for proper cooking and reheating methods to destroy microorganisms to safe levels, and it outlines requirements to minimize bacterial growth during cooling and hot and cold holding outside of the temperature danger zone. Chapter 4 of the Food Code discusses thermometers more specifically, and the requirement that establishments have ready access to thermometers, including a small diameter probe for measuring thin masses of foods such as hamburger patties or fillets. Also, in Chapter 4, there are temperature requirements around warewashing activities. In manual warewashing, specific temperatures for wash and sanitizing water temperatures. And in high-temperature dish machines, where there's no chemical involved and heat is the sanitizing agent, the FDA requires an irreversible registering temperature indicator for measuring surface temperature of items during sanitizers. So it's critical that food establishments have appropriate thermometers for the task to ensure safe food temperatures in coolers during preparation, storage, and warewashing. And since there are so many varieties of thermometers out there, we're going to review some of these devices and briefly discuss the benefits and potential drawbacks of each. First shown here is the bimetallic stemmed thermometer, a dial thermometer, which are widely used in the industry as they're very easy to use. They're relatively inexpensive, but one drawback is that they need regular calibration, and they're not suited for thinner food items, as the sensors are located in the bottom 2 inches of the probe, and they typically require deep insertion into foods, and they could take up to 30 seconds to get an accurate reading. A digital thermometer or thermistor is more suitable for measuring internal temperatures of thin masses of foods, as the tip is extremely sensitive, and this model would satisfy the FDA requirement for measuring temperatures of thin foods. It has a much quicker response time than the bimetallic stemmed, usually between 2 and 5 seconds. There are different versions of these thermistors or digital varieties and are a little more costly than the bimetallic stemmed thermometers. Thermocouples also have a fast response time, about 2 to 5 seconds in general. There are different types of probes for different uses. They're often purchased separately from the main unit. They can be used, these different probes are appropriate for measuring internal food temperatures, grill surface temperatures, and the probes are generally suitable for measuring thin foods as well. Some models have an extended cable which allows the unit to be located outside of the cooking equipment while monitoring food temperatures on the inside. Very convenient. The infrared laser thermometer measures surface temperatures. It has a very fast response time, which makes it convenient for measuring items on the line or in the salad bar. When using such a thermometer, though, we have to consider the distance to spot ratio when selecting your model. Some infrared thermometers require a closer distance to the surface than others to monitor food temperatures accurately. And one drawback of this device is that it may not be considered a valid measurement of food temperatures for the purposes of regulatory actions or legal matters. Disposable thermometers are designed for single use. These paper thermometers are preset with a material which triggers a color change when a particular temperature is achieved in the foods or on the surface of the item. The advantages are that we can retain the triggered paper thermometer for documentation. They need no cleaning or sanitizing before use, and they're available in different temperature designations. And they have essentially two applications in food service. First, in warewashing applications using hot water sanitizing. This thermometer would measure the surface temperature of the item in the rinse cycle. You'd most likely use the 160-degree Fahrenheit variety, and it would trigger when the surface item reaches 160 degrees, and it would satisfy the FDA code requirement for a maximum registering irreversible temperature measuring device in an automatic warewasher. In food applications, disposable thermometers can be used for measuring internal food temps during cooking, reheating, hot holding, and they are also suitable for measuring thin foods. You would, of course, use the appropriate temperature variety for a specific food measurement, and again, disposable thermometers can be retained for record-keeping purposes, which is a great advantage of these thermometers. A couple of factors to consider when using food thermometers. Calibration is critical to ensure accurate temperature measurements. Bimetallic thermometers are typically calibrated using the ice method, sometimes boiling water. Most digital thermometers can be calibrated in the field according to manufacturer's instructions, and if a thermometer is non-adjustable, they should be replaced or removed from service until professionally serviced. Cleaning and sanitation of thermometer probes is also important before use. Probe wipes are available in pop-up dispensers or as single-use packs. And probe insertion and holding time is also important. Manufacturer's instructions should be followed for a particular model, but in general, bimetal thermometers are inserted into the thickest part of the food at least 2 inches deep or up to the dimple that you usually see in the stem. Hold it for 30 seconds or until the needle stops moving. Digital and thermocouple probes generally have a 1/4-inch insertion depth and have a hold time of about 2 to 5 seconds, depending on the model. For infrared devices, it's important to remember that they measure the surface temperature only, and we need to consider the distance to spot ratio for your particular model and follow the manufacturer's instructions for accurate measurement. And the reading is instantaneous in these devices, essentially. In summary, best practices around thermometer usage, we want to make sure to refer to the manufacturer's instructions for your particular model. Consider the appropriate type of thermometer for specific use in your operation. Make sure that you always have access to calibrated, clean thermometers in the operation. Have a backup just in case. And document temperatures in record-keeping logs, and retain these records for a period of time as required by your company or as written in your food safety plan. And now I'll pass this on to Sarah Renke.
Thanks, Cindy. My name is Sarah Renke. I'm a lead technical account manager for our institutional division. And what I really do is I'm kind of the liaison for institutional with our R&D, our marketing teams, our field sales, as well as our customers. So what I'm going to cover for us today is a very commonly asked question in the food service industry around Quaternary ammonium as far as food contact sanitizers go. Three main topics: the differences in Quats and Chlorine and why we choose a Quat-based compound for a food contact sanitizer in a manual application specifically, and then Quat adsorption onto food service towels, and then finally testing requirements around testing the food contact in the use solution form. So first let's talk a little bit about Quats themselves. So we've got laid out here the advantages and the disadvantages. There's a lot of advantages to using a Quat sanitizer in a manual application specifically. It kills a wide range of organisms. It's non-corrosive to metals, and this is important because in the food service application you come into all different types of metals, most commonly stainless, but you also run into those soft metals, maybe aluminum or nickel, and Quats are non-corrosive to those soft metals as well. The chemical activity, it's not inactivated by organic soil. So this is important, especially in the Sani bucket application, as you're using the same solution to wipe different surfaces and you're adding soil to the used solution. It's effective at a broad range, pH, very important because we've got all different various types of waters out there. It's non-reactive to most surfaces, hard surfaces and soft surfaces. It's heat stable, so you can use it on hot surfaces or cold surfaces. And it's got a long shelf life, especially in a closed-loop system like a spray bottle, where it can't get contaminated by any outside source. So it does have a real nice long shelf life. A couple of the disadvantages around chemical activity, it's inactivated by coming into contact with anionic or negatively charged cleaning agents. So if you wipe a surface and then you wipe a surface again, it could potentially lose some effectiveness. The biggest one, though, is the adsorption onto cotton fiber cloths or any food service cloths, and I'll talk about that in just a couple of slides. Hard water tolerance. Hard water can reduce the effectiveness, but the caveat to that is it's effective up to 500 ppm or 30 grains of hard water, and that's extremely hard, and we don't see those water conditions very frequent. So it's got a very good hard water tolerance, but maybe not quite as good as chlorine. Temperature, as far as using it, the EPA as well as the FDA food code require a minimum of 75 degrees for a Quat-based sanitizer, and I'll touch on that at the end. And then also, if you were to use a Quat-based sanitizer in a mechanical operation, it would tend to foam. So chlorine, or most commonly called bleach, again, it does kill a wide range of microorganisms. It is corrosive. So I'll go over the disadvantages first. So it's corrosive to most common metals as well as rubbers, plastics, and even stainless steel. People don't think it's corrosive to stainless steel, but over time it will also corrode your stainless steel. It quickly deactivates in the addition of soil load. Again, with the advantage of the chlorine in the addition of soil load, the chlorine can deactivate very quickly in the addition of that soil. It's got a very strong odor. It's less pH. It's got a greater pH sensitivity, so it's really only effective in that mid-pH range, and also can produce a toxic gas if it gets to the low pH range, like pH 4 or below. And that gets after the toxicity as well, again, producing that gas that people just absolutely do not want to be around. And then it's got a high reactivity, so it reacts with various hard surfaces, soft surfaces, whether it be changing the color of a carpet or a uniform or something like that. And that can also be corrosive or reactive with skin. So a lot of people don't like, even at used solutions, sticking their hands in and out of a chlorine solution. And then the shelf life. It dissipates over time, and that time can actually be very, very short, and even can dissipate in a non-diluted form. So in a concentrated form, it still can lose effectiveness, so it has a very short shelf life. There are a couple of advantages, though. It does kill a wide range of microorganisms, like I said. It's got a broad hard water tolerance, and then essentially it's very inexpensive to use as it is a commodity item. So moving on, I'd like to talk a little bit about some internal Ecolab testing that we did around Quat absorption. So this is purely around Quats now, onto different food service towels. So we've tested 100% terry towels, and we see those most commonly in a food service application. That's really what we see the most out there. But then also varying levels of poly blends in the microfiber towel field as well. So the top two boxes across the top are actually with the 100% cotton, and we tested the solution directly from the cotton towel as well as the bucket solution over varying amounts of time. So the concentration at the initial, when we first made up the solution, after 10 minutes, 1, 2, 3, and 4 hours. Best practice is to change your solution after every 4 hours at a minimum anyway, so that's kind of how we determine the timing. So as you can see with the cotton terry towel, within the first hour, it oftentimes dropped below the 150 ppm, and we started at roughly 350 parts per million to start. So there's a lot of adsorption even right away with the cotton terry towel. And then the next 3 sets of data here are various blends of, we go from a 85-15, 80-20, and the 70-30 different poly blend type of microfiber food service towel. It does drop off, but it doesn't drop off as low, and it can also maintain for a longer period of time. So in summary, the largest concentration drop overall does happen within that initial first hour, so that's the addition of the towels. And eventually the towels, the solution in general, will all come to an equilibrium. It's just what is that equilibrium and how quickly does it get there. And like I said, the 100% terry cotton towels drop below the 150 ppm quite frequently within that first hour. And so the optimum towel type that we found in our testing is an 85-15 poly blend for the microfiber. So thinking about how to test quaternary ammonium. So we do have that requirement through the food code that quats need to be above 75 degrees. So best practice is to plumb them to hot water. And then oftentimes, depending upon the temperature of your back of house, they kind of settle into room temperature. And as long as they stay above that 75 degrees and they are in concentration, you're okay with going ahead and using that solution. So testing the quat is a very common question as well. How do we test the quat? So when we get it set up initially, it's tested with a very accurate chemical titration kit. And after setup, the daily or as-needed type of testing application is going to be a test strip. Whether it's a paper or plastic test strip, best practice for using those test strips is to absolutely follow the vendor instructions on the test strip and make sure that you're using the proper test strip that the vendor of the chemical requires for that particular chemical. So use the right one and make sure that you're using the test strip correctly. And correctly can be contact time, so are you dipping it for 1 second or 10 seconds? It depends upon each strip. And then also the temperature in which the strips are used. So with that, I'll pass it on to Ruth Petran for a FSMA update.
Good morning and afternoon, everybody, and thanks for joining us. I have the privilege of leading food safety for Ecolab and wanted to give you a brief update on FSMA, or the Food Safety Modernization Act, which we spend a lot of time thinking about here. And I'd like to particularly talk about how this relates to retailers, which frankly is not all that much, but it is a question that we've gotten on these webinars. So I just want to touch on it briefly for a few minutes. Basically, the Food Safety Modernization Act was signed into law by the President way back in January of 2011. And from the legal perspective, it was designed to enhance public health, and it requires that anyone who's producing human and animal food develop a food safety plan. There's also a focus on produce safety and a risk-based approach for FDA to inspections. There's also a caveat that relates to the safety of imports and ingredients. So bottom line, there's new responsibilities for producers of food and feed, new controls over imports, new controls for FDA, and some new fees to make sure this all works. This is a bit of an eye chart, but there's a couple big takeaways I want you to keep in mind. One is that regulation process in the U.S. takes a long time. As we can see, the proposed law was in 2010, again signed in 2011, and now we're in the time frame of late 2014. We have just finished a comment closing period, and now FDA goes back with those comments and will issue rules beginning about the middle to latter part of 2015. But nothing really takes effect for another year, so it'll be the middle to latter part of 2016 before implementation of these rules starts. So what does this mean for folks who are impacted by this? Really, this is a time to get ready and to think about what needs to be done. Who does need to get ready? Well, generally, it's those companies that manufacture, process, pack, or hold food that's consumed by human or animals in the U.S. that's regulated by the Food and Drug Administration. It does include things like fresh and processed produce and dairy, but there's some exemptions. First of all, most do not directly apply to restaurants, farms, retail facilities, and small businesses. And we'll talk, though, about some particular exceptions to that. There's also products that are exempted because, frankly, there's already rules that exist for these, including dietary supplements, juice, seafood, and alcoholic beverages. And this also does not include USDA-regulated meat, poultry, and processed eggs, but it would apply to the ingredients or additives that are used in these products. So what does this really mean for retailers? Well, basically, it depends on the complexity of the operation. Generally, for a retailer who simply just has stores or establishments, they need to think about produce safety and labeling and think about the reportable food registry, which relates to notifying consumers if there's recalled product for establishments that have more than 15 stores. Where FSMA really comes into play is for those companies who have central kitchens or off-site production facilities. For example, a dairy or deli facility perhaps that's supplying products to their operation. This is where the rules really take effect. And in addition to the things mentioned above, that facility needs to be registered, needs to keep records, put together a preventive control plan, and consider things like foreign supplier verification, food defense plans, etc. In addition, those retailers or wholesalers who might have a distribution center, they need to be cognizant of the information above, but also think about requirements related to sanitary transportation because there is a rule that relates to that as well. For those operations with solely a distribution center or truck fleet, they need to be concerned with some of these, including facility registration, record keeping, various risk assessments for their particular distribution center, also foreign suppliers if that applies, and then sanitary transportation as well. And finally, a facility like that above that imports produce, they also need to be thinking about foreign supplier verification. So bottom line, it really depends on the complexity of the operation, but for most establishment-only type companies, there's not a lot that needs to be done, but there is should be consideration of how this could affect you or your suppliers. So what's next? We just finished a comment period on 4 of the rules that had been reproposed, including produce safety, where there were some updates to information about water quality and testing, preventive controls for human foods, where there were updates to requirements on product testing, environmental testing, and suppliers, and also changes related to farms. In the preventive controls for animal food reproposed rule, there were also similar changes as in the human food rule, or those facilities who are providing a byproduct that might be deployed to make animal food. And then finally, adding more flexibility to the foreign supplier verification program in order to determine what verification needs to be done. So at this point, we go back to a sort of closed session with FDA reviewing all the comments and publishing final rules. They are required per a judicial court decision to start publishing rules as soon as the end of August in 2015, ranging into 2016. So at this point, we're in a wait-and-see mode, and it is, though, a time to get ready. So at this point, my best advice on FSMA is wait, but be prepared for what might be coming. We now will enter a question and answer session, which will be moderated by Miriam, and as shown on the slide are those of us who are available to answer questions.
Thank you, Ruth, and thanks to all of our presenters today for our little mini sessions. I know some of them are kind of a bit of a tease on a longer topic. And I'll mention that coming in 2015, we do already have quite a bit of our calendar already put together, and that will include a more detailed 1-hour presentation relating to norovirus, which we just touched on in the biohazard portion. I'm going to take a couple questions and try to spread these out to the presenters, and obviously any of our other experts on the line can jump right in. I believe these would be for Frank. Where is the best place to measure the temperature of a machine and to measure the concentration of a sanitizer in the machine?
Okay, in terms of temperature, by law, all dish machines must have some type of temperature measuring device that's visible to the operator. So in other words, you should have a temperature gauge that would register the wash temperature, and also a second gauge that would register the final rinse temperature if you were going to be doing a hot water sanitizing step. Additionally, there are temperature strips, as indicated in one of the previous presentations, that you can utilize, and these temperature strips would either be placed on the rack that's inside of the dish machine or affixed to the rack or a piece of wear, and then as soon as the cycle's done, you can pull out the rack and read the temperature strip. In regard to testing sanitizer solutions, I'm assuming we're speaking specifically of a chemical sanitizer. Again, you would run the machine through a complete cycle, pull the rack out, and take the appropriate test strip, depending on your sanitizing agent, which in about 99.9% of the cases is going to be chlorine, and you would immediately touch that strip to a wetted part of the rack and read what the results are. You should be between about 50 and 100 parts per million of available chlorine. I think that should answer that.
Okay, well, thank you, Frank. And there's a couple related to norovirus and biohazard cleanup, and I might also ask Ruth Petran to step in here with me. How long does norovirus remain viable on surfaces? And it's my understanding that it does depend on the surface, but on hard surfaces it can be up to several hours. Ruth, would you like to elaborate on that a little more?
Yeah, it's actually a little worse than that. It depends also on temperature and the level of moisture that's on the surface. And generally, we've seen persistence under dry conditions at room temperature for the longest time. If we add a little water, we can see a little bit more die off. And then as we cool things down, we see a little less survival. So many, many days at room temperature on a hard surface is kind of the rule of thumb.
I think it's also important to mention, again, there are specific disinfectants that are to be used to get rid of norovirus contamination. So you may have your typical sanitizers and other cleaning chemicals that are available in the back of house, but using them will not necessarily clean up norovirus. And that's why you should work with your chemical provider in terms of what chemicals do have the specific declaration to be effective against norovirus. Now here's another question which I had not thought about before. Do you recommend disposing of the disinfectant bottle after a cleanup procedure because the bottle exterior will be contaminated? Do you have any comment on that?
There certainly could be a risk from that. I would look to the evidence of potential transmission from that surface, and I'm not aware of any concerns with that. But if someone truly is concerned about that, that could be a prudent step to take.
Or else, as the bottle is a hard surface, you could simply disinfect the outside of the bottle. And we know, like Miriam said, with the appropriate chemical sanitizer with an EPA-registered norovirus claim for the appropriate contact time. And I think that would also mitigate that risk.
And I'll mention that in my brief presentation, I actually neglected the very last step, which is going back to thorough hand washing. Poor hand hygiene is another method of spreading norovirus. So for the person who is involved with cleanup, once they've disposed of all of the materials appropriately, a thorough hand washing is also very important. So don't neglect that one very important step. This one, I believe, would be for Cindy, I guess. Is using a sanitizer solution in a cup acceptable for sanitizing thermometers? I think what they're talking about here is I've seen sometimes like a coffee cup that has a hole in the top, but they just leave the stem thermometers or those kind of the different probes soaking that way.
Well, after use, the thermometer should be cleaned off. The stem should be cleaned, and then if you wanted to store it in a sanitizing solution in between uses, that might be acceptable as long as it was changed appropriately, probably daily. I know there are some solutions that you can buy for that purpose, but you want to be clear that if you use a thermometer into the interior of the food and then stick it in the sanitizer, the food particles may interfere with the sanitizer action, so it may be a false sense of security unless you clean the stem first.
Okay, and Sarah, did you have any comment on that?
I think Cindy took care of it, honestly. I think that if you hold it, to your point, you need to make sure that the solution is the proper concentration, and then it is completely air dry before you go ahead and use it again.
Great, thank you. Mm-hmm. And this one is for you, Cindy. I'm sorry, for Sarah. Are you supposed to use cool water when sanitizing with chemicals so the water is 75 degrees, or in other words, why would it be bad to use hot water with sanitizers?
It's actually not bad to use hot water with sanitizers. It's what we recommend. So the lower limit is the 75F. There is no upper limit. Specifically speaking about Quats here in the manual application, there is no upper temperature limit. So our best practice is to have your Quat dispenser plumbed to hot. That being said, in the manual application, you are sticking your hands and such into the solution. So the issue with super hot temperatures is potential scalding, those types of things. But as far as chemical effectiveness, there is no upper limit.
Okay. But what about with chlorine sanitizers?
Off the top of my head, I'm not 100% about the chlorine sanitizers, but those usually come into play with the dish machine, and they're always used for the most part. I mean, the minimum's like 140 degrees with the dish machine, so those are also effective on the hot water side. What the exact temperatures are, I'm not specific off the top of my head, but they are safe and effective in hot water as well.
Okay.
This is Frank. If I can comment on that as well. With chlorine sanitizers, you want to try to stay 150 degrees Fahrenheit or less, because as you exceed that temperature, the chlorine actually starts to flash off or gases off. So it is good up to a certain temperature. I mean, it still will be effective, but it will dissipate much quicker as the water temperature starts getting increasingly hotter due to gassing off.
Thank you. And you mentioned, Sarah, with the Quaternary sanitizers, those can be in hot water, but it needs to be cooled for testing. Is that correct?
Right. So this is the conundrum that we often run into around. I see the question here specifically around our multi-quat Oasis 146, and the temperature test strip is required at room temperature of 75 degrees F. So though we're saying that in compliance with the food code, it needs to be hot, and we need to change those solutions at 75 degrees. You want to be sure that you test those with the test strip at room temperature. And what that comes down to is the way that the test strip is built. It's the test strip that we have that's available that works best with the Oasis 146 multi-quat, again, with getting back to using the proper test strip for the particular chemical. And I know exactly what this is referring to. So best practice is to pull out an aliquot of solution and test that solution, because a smaller aliquot is going to come down to room temperature much quicker if the solution is hot. So pull out an aliquot of the solution and then test the solution from that aliquot. It may not be the most time and efficient way, but it's truly the way that the strip is manufactured and what we have available that works. I know it's kind of a conundrum, but it is what it is.
Okay. Thank you. And as always, look for the labels for instructions on the different products in terms of how you should be using them and testing them.
Absolutely. And there's always instructions right on the test strip container to how to use those specific test strip time and temperature requirements.
Okay. Very good. And for Ruth, regarding FSMA, would convenience stores with ready-to-order food be included in the changes to FSMA?
If it solely is a convenience store chain that's only making and selling food on site and not at an off-site, say central kitchen or manufacturing plant that would be, routinely inspected by federal FDA or USDA inspectors, they would not be required to comply with the majority of the changes in FSMA. However, if they have more than 15 retail locations, they would be required to post information about foods that were recalled, for example, under the reportable food registry, which is related to FSMA, but actually not exactly part of the current requirements. But that would be the only thing. But if, again, that convenience store has a central location or kitchen, commissary kind of place that's a registered facility, they would have to comply with FSMA.
And is the retailer responsible for the labeling requirements or the distribution center?
Labeling for what?
The question that says the retailer responsible. This says labeling requirements for under FSMA.
There's the company is responsible for that.
Okay.
So who's ever selling that, I would say that the parent company is ultimately responsible for that.
Okay. Thank you. And Dr. Barquet, people did not forget about you. Is it true that cockroaches and mice tend to run along baseboards rather than out in the middle of the floor?
Well, these are critters that do like to be up against edges, and cockroaches especially in cracks and crevices. So we typically don't see them out in the open very often. They're usually hidden. They're cryptic. They're not comfortable being out in daylight and stuff like that. One thing we need to be cautious about is that baseboards can be an area, especially where cockroaches can be, but they are much more prevalent in the food areas of kitchens and such. So that's where the focus is typically on equipment as well as cracks and crevices within those areas because there's a lot of food debris. And so it needs to be, from the standpoint of where you're targeting these pests, they're, again, typically hidden and in voids. So not out in the open so much, and if you do see them out in the open, it typically is an indication that there's a severe infestation. So again, they tend to be more hidden.
Very good. And then also for you, what is the best treatment to rid a bar area of gnats other than cleaning all the surfaces with sanitizer water?
Yeah, those are actually probably fruit flies, and they're the dark-eyed fruit fly, which is relatively new species that we're seeing in restaurants. About 15 years ago, we started seeing them. And they breed in very stagnant areas where there's fermenting organic matter. So that all needs to be cleaned up, and your pest management provider should be able to do an inspection and find the breeding areas. It's not just going to be drains, but it can be place voids and such where liquids are seeping, becoming stagnant, and providing breeding areas. So they're one of the most difficult pests to eliminate from a restaurant, so you need to have a very knowledgeable service provider that can help you through that.
Very good. Thank you. And let's see, here's a general question here. What is the maximum time limit for raw meat at room temperature thawing? Well, there's a couple different issues in there. Raw meat should be thawed ideally in a cooler where none of the surface area or internal area would get below, or would get above, rather, the ideal 41 degrees Fahrenheit. So what you really want to do is if you have to do a quick thaw, you can thaw the meat in under cold running water that's at 70 degrees or colder. The meat could be cut into smaller portions and then put into the cooler, or it can be thawed in the microwave. But for good, proper food safety practices and to comply with local food codes, meat should not be thawed just at room temperature or in standing water. And I think with that, we have actually run out of time. This has been just a really great conversation today. We hope that you've enjoyed this different way to end the year. A recording of this presentation will be available this coming Friday at the address that's shown here. If you don't write down the entire thing, if you go to ecolab.com and just under search, look for webinars or presentations, you'll be directed in the right direction. And we hope that you'll join us in January, on January 20th, where Dr. Petran will speak about the New Year's resolution, keeping it clean in 2015, common violations and best practices. We will have a great lineup for webinars next year, and we want to wish everybody a great holiday season. And don't forget, at the end of the webinar, you will get a pop-up survey, and this is where you ask for your continuing education certificates. And don't forget, you can also go to the ecolab.com website and look at the webinars, and you can replay today's, or you can also replay any of the last 4 years' worth of webinars, and then you send an email to me for continuing education. And I'm at miriam.eisenberg@ecolab.com. So again, thank you for joining us today, and we look forward to speaking to you next year. Thank you.